5 months ago, everyone was talking launch. It was all over the news. People were excited, but things didn't go as planned, and there was an explosion over the Gulf of Mexico. Even with that setback, everyone was glued to their screens. If that launch got so much attention, just think how much more excited people will be when they get it right next time. Recently, Musk expressed confidence in the Starship's second launch. He indicated that the chances of the Starship reaching orbit in its upcoming attempt are significantly higher. Furthermore, he hinted at a possible launch date for the second liftoff. Before we delve deeper into this topic, make sure to subscribe to our channel for future updates about the Starship and other SpaceX missions. SpaceX, under the guidance of Musk, has been working tirelessly to make Starship ready for the next orbital launch. About a month ago, Musk hinted at the readiness of the Starship. In a tweet dated September 6th, he informed the world that Starship was launch-ready and only awaiting FAA license approval. This was a significant step for SpaceX, especially given the rigorous tests and modifications the prototype had undergone. Musk's recent optimism about the upcoming Starship flight isn't just blind confidence. In fact, the SpaceX team has undertaken more than 1,000 modifications to both the Starship and its booster since the last flight. Recall that on April 20th, Starship's monumental orbital test showcased the union of the S-24 and B-7 pair prototype. This behemoth, standing at an impressive 120 meters, even surpassed the legendary Saturn V rocket in height, but the celebration was short-lived. Within minutes of soaring, a disastrous explosion emerged due to the 2 stages of the Starship failing to part ways, leading SpaceX to make the tough call of detonating it over the Gulf of Mexico. A primary concern from that April flight was the malfunctioning separation system. But SpaceX didn't just sit on its laurels. They unveiled the hot staging mechanism. This clever solution involves a vented ring placed between the 2 stages, allowing the second stage to ignite sooner without causing harm. This innovation alone significantly boosts the chances of a successful flight. So, when Musk conveys confidence in the next launch, boasting a predicted success rate of 60%, it's backed by the tireless efforts and numerous enhancements SpaceX has poured into the project since the last attempt. The April flight, aside from the stage separation issues, revealed significant concerns with the engine systems of the Starship. Specifically, the nozzle system manifold and the hot air ducts encountered problems which were grave enough to result in fuel leaks, leading to the untimely failure of the engine. Understanding the complexities and the potential perils that these issues posed, SpaceX initiated a comprehensive analysis of the engine's infrastructure. Their investigations highlighted vulnerabilities in the design, especially in the areas exposed to extreme heat and high pressure. Addressing these, SpaceX fortified various components to endure the rigorous conditions presented by rocket flight. Materials resistant to high temperatures and capable of withstanding tremendous force were introduced to the nozzle system, significantly reducing the chances of malfunctions similar to those observed in April. Furthermore, the engine's ignition system underwent a series of enhancements. The improvements aim to ensure a smoother and more reliable startup sequence, which is crucial for the overall performance and safety of the flight. Perhaps the most notable modification was the shift in the control system of the engine. SpaceX transitioned from a hydraulic thrust vector control, or TVC system, to an electric one. This new electric TVC system is not only more efficient, but also offers a more precise method for controlling the engine's direction. By eliminating hydraulic fluids, the electric TVC reduces the risk of leaks and ensures a cleaner operation, thus increasing the engine's reliability during the flight. The ramifications of the explosion were not limited to the rocket alone. The launch pad bore a testimony to the destructive might of the malfunction, with a gaping hole left in its wake. Addressing this, SpaceX introduced the water deluge system. By spraying water through tiny holes in a hexagonal steel plate, this system dissipates the heat and pressure from the Raptor engines, ensuring the safety of the launch mount and nearby structures. With technical hitches being steadily addressed, the question naturally arises: is Starship primed for another launch? From SpaceX's vantage point, the response is a resounding yes. The primary hurdle remains regulatory approvals. As of mid-September, SpaceX confirmed the completion of 57 out of 63 required corrections, with strategies in place for the remaining issues. However, the U.S. Federal Aviation Administration remains cautious. While SpaceX claims readiness for the subsequent flight, having incorporated all necessary modifications, the FAA is yet to award a license for the next launch. Additionally, the U.S. Fish and Wildlife Service has its own set of environmental assessments to conduct, a process that can span between 35 to 130 days. Ironically, while SpaceX seems to have had their rockets ready for launch ages ago, they're still left twiddling their thumbs waiting on, of all things, a piece of paper: the launch license. It's almost comedic to think of this cutting-edge technology, raring to go, yet grounded by bureaucratic delays. It makes one ponder, would the iconic Apollo rockets have ever taken off if they were under the same stringent regulations? Or is there a more political angle to this delay? Rumor has it that the current administration isn't exactly on the best of terms with Musk, SpaceX's audacious owner. And Musk? Well, he's no stranger to these political games. He recently expressed his fury over what he perceives as bureaucratic delays. A tweet drew attention to the impending review by U.S. Fish and Wildlife officials, saying, U.S. Fish and Wildlife officials have yet to begin a formal review of SpaceX's upgrades following Starship's first launch in April. This could push back the next launch window by months, which I know none of us want to hear. Musk's irate response was immediate. That is unacceptable. It is absurd that SpaceX can build a giant rocket faster than they can shuffle paperwork. The future of space exploration might be happening now, but it seems the old rules of earthly politics still apply. And most recently, when asked about predictions for when Starship might achieve a crewless landing on Mars, Musk replied, "I think 3 or 4 years." He elaborated on Starship's potential capabilities, envisioning scenarios like breakfast in LA, lunch in London, dinner in Singapore, and then back in LA for bedtime. Adding, "I think it's sort of feasible within the next 4 years to do an uncrewed test landing there." While Musk emphasized not wanting to set expectations too high, he conveyed his long-standing ambition for the Starship rocket to facilitate the landing of humans on Mars. Nevertheless, the clock is ticking. NASA has commissioned Starship to ferry the Artemis III crew to the Moon by 2025 or 2026, marking the first human lunar landing since Apollo 17 in 1972. This ambition is underscored by the sheer power of Starship and its Super Heavy booster, which dwarfs NASA's Space Launch System in terms of liftoff thrust. And that's all for today's update about the Starship. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.
And greetings from the 74th International Astronautical Congress here in Baku, Azerbaijan. I'm Clay Morey, president of the IAF, the world's largest international space organization with over 500 members from 77 countries around the world. It's my privilege today to host this live stream chat with Elon Musk, who's chairman, CEO, founder, and chief technology officer at SpaceX. Elon is also the winner of this year's prestigious IAF World Space Award that recognizes his exceptional impact on the progress of world space activities through his outstanding contributions in space technology and space management. Welcome, Elon.
Thank you. Thanks for having me.
Elon, I don't know if you can see, we have a huge packed auditorium here in Baku with a huge also live audience. We're streaming this on X and on the IAF web app, so thank you for joining us today. Let's talk rockets.
Absolutely.
All right. Let's talk really big rockets. Okay, let me take you guys back in time a little bit. 15 years ago, I think it was a week past, SpaceX successfully, on its 4th attempt, launched the Falcon 1 to space, to orbit. And I think it carried, if I'm correct, a 165 kilogram payload. Today, you're,
yes,
oh, go ahead.
it was just a test payload on the 4th launch, so no actual satellite, because the first 3 launches unfortunately had failed. So we didn't want to risk the 4th launch with an actual satellite. But we're very happy to have launched a Malaysian satellite on the 5th launch of Falcon 1. Yeah.
Fantastic. So let me make the contrast. Today, you're preparing for the 2nd launch of Starship, which has the ability to launch up to 150 metric tons in a reusable configuration. If I'm doing the math, and you're better than this at me, 900 times the capability, roughly, of Falcon 1? Am I getting?
Yes. Falcon 1 looks like a child's toy by comparison.
It's a staggering achievement, what you've done in 15 years, and all the team at SpaceX, I think we're all just in awe of how fast that progress has been made. And to pioneer reusability for orbital launch systems is, I think, something to be tremendously proud of, both for you and the team there. It stands, this vehicle now, I think something like almost 400 feet tall, roughly over 120 meters. It's a massive Starship spacecraft and super heavy rocket itself, collectively known as Starship. And it produces more thrust than the SLS system, the Saturn V, and Russia's old N-1 rocket. Is that correct?
Yes, the current version of the Starship produces just over twice the thrust of Saturn V. And with the upgrades we have in the works, it'll do about 3 times the thrust. So Saturn V in the sort of old Imperial system would have been 7.5 million pounds of thrust. We're at about 16 right now, and we with future engine upgrades, we'll take that to about 20 million pounds of thrust.
Amazing.
Yeah.
Simply amazing. So I know you guys have said you learned a lot from the April 17th, from this first launch attempt. There's been some upgrades to the vehicle. I think it's a Booster 9 now that you're launching with Ship 25. Is that correct? Geeking out on the numbers. Yeah, the kids that follow online.
These numbers are maybe a little, it's not quite the 25th booster, because what would happen is we would redesign we'd make a new design, and then we'd actually scrap units that were in progress. So it's 25 is perhaps, it sounds like we built 25 units, but we haven't actually built 25 units. We built probably about 12. Still a lot. Yeah, so but the way you think of it really is that this is Flight 2, and has a number of upgrades on both the ship side and the booster side. We've done a lot more with engine isolation, which is incredibly important. We've tried to draw as many lessons as possible from the Soviet N-1 rocket, which is probably the closest in design to Starship. I believe it had 29 NK-33 engines, if I recall correctly. That was quite a high thrust rocket. And unfortunately, I think actually that rocket, on all things considered, was a great design, but did not receive sufficient ground testing, so never made it to orbit. But that would have been the sort of the closest, probably parallel to Starship. Really the biggest difference, the most fundamental difference of Starship is that it is designed to be fully reusable, with both the booster and the ship, or both the first and second stage are designed to be fully and rapidly reusable. So for a truly profound revolution in mass to orbit, you have to have I call it the four R's: rapidly reusable, reliable rockets. RRR.
I love it.
Like a pirate.
R. Everybody give me an R. R. Give me an R. All right. So what does success look like for this flight number 2? What does success look like for you? What are you trying to achieve?
Well, I do want to set expectations, not too high. So there's a tremendous amount of new technology in this rocket. We have actually changed the entire stage separation system from something that was, I'm not sure how to describe this, but kind of just a rotation and flip. We're trying to move to a passive stage step system where you don't have pushers, essentially. To try to eliminate parts. There's no pushers, no interstage like Falcon 9 has. With Flight 2, we're actually trying to do hot staging. So hot staging would mean that we light the ship or upper stage engines while the boost engines are still partially thrusting. So we throttle down and shut down most of the booster engines. Then we light the ship engines, and there's a vent area which looks comically small, actually, which hopefully is enough.